Section 6.8, Formulas. Formulas occur frequently in mathematical models. Many formulas contain rational expressions or fractions, and to solve such formulas for a specified letter, we proceed as we do when solving rational equations. In this first example, they're asking us to solve for capital V. And the first thing we need to do is to eliminate or clear the fractions. Our least common denominator is a capital T and a T, but in this particular formula, because we have a ratio equal to a ratio, we have an alternative to multiplying both sides by the least common denominator of capital T, lowercase t. We can use cross multiplications. Cross multiplication, multiplying this diagonal, PV times lowercase t, is equal to multiplying the diagonal in this direction, capital T times PV. With the use of cross multiplication, we've eliminated the fractions. Now we are on the journey of isolating V and solving for it. And if we look, capital V is only in one term. It is multiplied by a capital P and a lowercase t, so to get V by itself, we'll undo the multiplication by dividing both sides by PT, maintaining equality. The capital P over P cancels out, the T over T cancels out, leaving V. There are no terms common, so there's nothing to simplify here, and so our answer, or the transformation of this formula, solving for capital V, is the following expression. In this next problem, we're given this equation, and they're asking us to solve for C. And similar to the last one, to solve for a rational equation, we want to clear the fractions. And if we look, we have an A, a B, a C in the denominator, so our least common denominator is A, B, C. So each one of those fractions needs to be multiplied by ABC to maintain equality and to eliminate the denominators. So we'll multiply each fraction and then clear the fractions by simplifying. We're multiplying fractions together. Anytime there's a common factor in the numerator and the denominator, they cancel out. A over A is equal to 1. This leaves us with a BC times 1, or BC. In the next term, ABC is understood to have a denominator of 1. The B's cancel out, equal to 1, leaving AC times 1, or AC. And similarly, the C's cancel out when we multiply these two terms together and leave us with AB. Now our goal is to get C by itself. We have C in two terms here, and so to get C by itself, we're going to factor the C out. Factoring is like dividing. We're dividing the first term by C, which leaves a B. We're dividing the second term by C, which leaves an A. By factoring, we have isolated C, and now to get C by itself, we'll undo the multiplication. It is being multiplied by the quantity B plus A, so we'll need to divide by B plus A so that those cancel out, leaving C by itself. But to maintain equality, we also need to divide the other side by B plus A. As I said, these cancel out, leaving C. And this binomial is not common in the numerator as far as a factor, so we can't do anything for simplifying this. Someone may have an A plus B, which is equivalent to a B plus A for a similar version for solving this equation for C, which would be perfectly fine. One more example for taking an equation that has a rational expression in it and solving for a specified variable. In this problem, they're asking us to solve for capital B. This actually is a formula for the area of a trapezoid. And we have a fraction or a rational expression. So first steps, get rid of the fractions. We'll multiply by the least common denominator, which is 2. And to maintain equality, we will multiply both sides by 2. So we're taking 2 times the left-hand side as well as the right-hand side. Nothing to be done with 2a, but we have multiplication here of 3 things times this binomial. We can only multiply 2 things together at a time, and there's where our fraction or rational expression is eliminated. A number times its reciprocal cancels one another out, leaving a 1. 1 times h is h times the quantity b plus b, lowercase and capital. Our task is to get capital B by itself, and before we worry about the nitty-gritty details, we're going to peel away the layers, and the next thing that needs to be eliminated is the multiplication by h. To undo multiplication requires us to divide. On the left-hand side, nothing is similar, so we'll leave that as is. The h over h is equivalent to 1, leaving the sum of the 2 b's. And now the last thing left is to get capital B by itself. We'll subtract a lowercase b from each side. The quantity 2a over h minus b. Nothing similar, so we'll leave it as is, and gives us the quantity b. Now, if we wanted to simplify this, we would have to have a common denominator, but we have accomplished the goal of getting b by itself.